Good morning, year three. I hope you're well and ready for your half term, which is coming up very soon. But I also hope you're ready to do some wonderful recap of your times tables today. When Miss Ashford showed me, and I've seen a few of the guys in class as well, who've been doing the assessment paper recently relating to multiplication division, I saw that bar models were a bit of a sticky subject for us. So I thought what we could do is go over using them a little bit today and see how they can help us with our division and our multiplication. Be successful today, we're going to remember what our multiples of 4 and 8 are. We're going to discuss, so I'm going to be doing the talking. You can talk to me as well. You'll have to talk really loud if I'm going to hear you. We're going to talk about how they can help us, and then we're going to solve some pretty simple questions linked to them, but hopefully they'll help us understand how they're useful. Okay, guys, first job. First thing we've got to do to be good at this is our our 4 and our 8 times table. So there's a big red and a big yellow or orange block there, and there's going to be a timer. We've got 2 minutes then to try and fill in all these gaps. Okay, now if you want to copy out the factors for each of these, you can do so. You could write 4 times 0 equals and then write the answers. Or what you could do if you're being a bit cheeky, a bit lazy, is just write the missing numbers, okay? You've only got 2 minutes though, so I suggest maybe go for the missing numbers unless you're super quick like Maya and Dominic and can get them really quickly done. And Leah, I bet you're good at these as well. Now, I think it's only fair if I compete with you. So I'm warming my hands up because my heating's not working very well. And then we can have 2 minutes. Are you ready? Got a pencil? Got a piece of paper? If you haven't, pause the video. Get on. Ready? Steady. Go. Okay, 4 times naught is. Oh, I forgot to press go on the time. You've got some extra time, guys. You lucky so-and-sos. Now on to the divisions. Can I get there? Can I get there? Oh, Davin's going to beat me. Davin's going to beat me. Isaac's doing really well. Oh, Jaden's got lots of these done already. 10 seconds to go. Just about did it. Okay, I hope you managed to do it. Did you get it? Let's check if we're right. Okie dokie. So 4 times naught is naught. 4 times 1 is 4. 4 times 2 is 8. We go 12, 16, 20, 24, 28, 32, 36, 40, 44, and 48. If you look in the ones column for each of those, so 4, then 8, then 2, then 6, then 0, then 4, then 2, then 8, then 2. Each time it's a gap of 4. If you also look at them, all of them are even. So if you get an odd number and you say it's a multiple of 4, you say it's a product of a number including a product of 2 factors and one of them's 4, you're wrong. Because always a multiple of 4, a product of a number in the 4 times table is always going to be an even number. If you look at your 8s then, 0, 8, 16, 24. Ooh, also even, aren't they? Oh, 0, 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, and 96. You can see through those that they're all even as well. The gap between the ones here of 8, then 6, so it's going down by 2 each time, isn't it? Because 8 is less than 2 less than 10, and therefore we see that pattern of 8, then 6, then 4, then 2, then 0, then 8, then 6, then 4. So you see that little pattern. Okie dokie, guys. Hopefully you've spotted some other patterns. We'll talk about those when you get back. But now we've practiced our times tables. Now we think about how we can use that knowledge. Now, this doesn't look like a bar model at the moment, but it's almost like I've split my array of tennis balls into a bar. Now, there's bars along the top, and each one of these is made up of 4. So it's 10 lots of 4 is 40. Okay. And that's like this almost. Now, here, how many lots have I got? So if I think before I had 10 lots of 4, here I'm saying I've got 7 lots. So there's the little bars at the bottom, and there's 7 of those. Each one of those should have 4 in. The 4 add 4 add 4, add 4 add 4 add 4 add 4. So 7 times 4 is 28. Okay, that's how bar models represent the whole. Okay, it's a way of breaking down elements of either a question or a calculation. Important to remember though, double 4, double 2 is 4, and double again is 8. Double 24 is 48. Double 9 is 18. So doubles are really useful because double 2 is 4, double 4 is 8. So if you know your 2s, Darcy, you know your 4s. If you know your 4s, yeah, you know your 8. Okay, now, what I've just said then, I can tell you that what can I tell you here? I can tell you that 4 plus 4 plus 4. So 4 plus 4 plus 4 plus 4. Plus 4 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 plus 4. So 14 lots of plus 4 is 56. Well, I've said that double is the same as the inverse of half. So, well, if it's 14 lots of 4, how many lots of 8 would it be? Would it be 28 lots of 8, or would it be half as many? Because 4 is half as big as 8. So if I double 4 to make 8, then I halve my 14. So it's 8, add 8, add 8, add 8, add 8, add 8, add 8. So it's 7 lots of 8, which makes 56. Okay. So it's 7 lots of 8. So if I halve one of my factors, so I've halved from 8 to 4, I've halved that factor, then I double my other factor. So my other factor, rather than being 14, I've now got 7. Okay, so you've got to do the opposite to the other one. So here we can see, is this true or is this false? This picture of some Numicon. So how many pieces of Numicon have I got there? 1, 2, 3, 4, 5, 6, 7. Now 7 lots. Okay, so it's 7. I can see that one of my factors here is 7. Each lot has 8 holes in, so each piece has 8 holes in. So I know I'm looking at 8 lots of 7 or 7 lots of 8, whichever way round I put the factors. Now, hang on a second. 8 plus 8 is 16. Plus 8 is 24. Okay, so I know that 3 times 8 is 24. Now, 24 doubled is 48. So 3 and 3 lots of 8 is 48. Ooh. Now, that's 8 times 6 then is 48. 8 times 7 will be 8 more, wouldn't it? Which is 56. Yeah, okay. If I know that 3 times 8 is 24, I know that 6 times 8 is 48, and therefore I know it can't be 8 lots of 7. Okay, guys, here's some number bars, and here's some bar models you can see. So I can see that there's 4 groups of my 8. So what would that be? Okay, and then I can see on the right hand side, the green, I've got 5 in each column, and there's 1, 2, 3, 4, 5, 6, 7, 8 columns. So that's basically saying 5 lots of 8, and there's 4 lots of 8 over on the other side. So which one's going to be bigger? 5 lots or 4 lots? Let's see if we're correct. Okay, and then looking at my yellow, I've got 3 in each column, and there's 1, 2, 3, 4, 5, 6, 7, 8 columns. And on the right-hand side with my bar model, I've got 2 in each of my little boxes, and there's 8 of those little boxes. So which is going to be bigger? 3 lots of 8 or 2 lots of 8? What do you think? Well done if you've managed to clock this. The green 5 lots of 8 is going to be greater than 4 lots of 8, and the yellow 3 lots of 8 is going to be greater than 2 lots of 8. Okay, or 8 lots of 2. It's 8 lots of 2, really, isn't it, rather than 2 lots of 8. Okay, I said that incorrectly. And it's important we remember that, because although our factors can be swapped around to make the same product, When we're looking at that bar model for the 2s, it's 8 lots of 2. When we're looking at the bar models for the 8, it's 4 lots of 8. So it's important we use that correct terminology. So I was a bit naughty then. I said the wrong thing, so sorry about that. Matilda and Tim then, hopefully they're not going to be naughty and get things a bit twisted up. Now, Matilda said there's 10 lots of 8 and 10 lots of 8 equals 80. Tim over here says there's 11 lots of 8 and 11 lots of 8 equals 80. 8. Okay, now, both of them have done their correct multiplication. But if we look, can we see who's correct, whether it's Matilda or Tim? Matilda, because what she spotted is that there's 5 in the top row and 5 in the second row, and double 5 is 10, and therefore 10 times 8 is 80, okay, if they've got 8 petals on each of them. Tim's calculation that the two factors of 11 and 8 combine to make the product of 88 is correct, but it was the wrong calculation to do. So we've got to be careful, like we do with our reading, that we read the correct question carefully before we try and answer it. Right, guys, as I say, I'd just like you to familiarise yourselves with bar model as a concept. So this is just some pretty simple bar model work for you to do. Just have a go at going through them. We'll do some more of those in the videos after half term. Sorry, not after Christmas. I'm not buying you presents, guys, and nobody's going to come down chimneys. But if you can just try and solve these, just so you're familiar with filling in using bar models, they're really useful. They're really useful. Mrs. Spring's brilliant. My kids are great. My cat's brilliant. But I love bar models too. They're fantastic. Okie dokie, guys. In your sheet today from your new video, you've also got some work around adding money. And you can see, not just with multiplying and dividing, bar models are great using when you're adding. They just show you you've got these two values here that you're adding to make your bigger value of your whole. They're just really useful for painting a picture in your head of what you're being asked to do. Okay, so you can see they're being used there by the professionals who are super experts as well. Got some answer sheets coming today, so hopefully the work that you've done on money so far, you'll be able to double check with that. Try and if you're buying anything with mummy and daddy online or anything over the holiday, or if they're doing their shop online, can you help them work out how much it would all cost? Can you help them with that? Or if you get anything in the post that has a catalogue, can you try and add some of those values up as well and see which currency you'd use to do it? Thank you for all your attention in half term year 3. I know it's been tricky, but it's been lovely getting to know some of you through the fantastic work you've been doing, and I'll see you soon. Bye bye.